Assalamu alaikum wa rahmatullahi wa barakatuh. In today's video, we are going to talk about how to calculate the true rate of return or the return on invested capital RIC for mixed investments. If you remember the previous lecture, we were classifying investments, we classified investments into pure and mixed investments. A pure investment is the investment where the company doesn't borrow money from the project and we can test it if the project balance at every year is less than or equal to zero, then the investment is pure. يعني إذا كان البروجكت بالانس حسبنا البروجكت بالانس عند كل سنة وكان نيجاتيف أو يساوي صفر, then we say that it is a pure investment, and every simple investment is pure. On the other hand, mixed investments are the investments where the company borrows money from the project. Okay, and how to know if the project balance at any year is greater than zero, يعني positive, then it fails the net investment test and it is a mixed investment. And every mixed investment is non-simple, but the opposite is not always true. يعني كل mixed investment هو non-simple لكن العكس ليس بالضرورة انه يكون صحيح. And we saw that to decide for pure investments, the rule is simple. Just calculate the internal rate of return for a project, and if the internal rate of return for the project is greater than MARR, we accept the project. For mixed investments, we need to calculate the RIC, return on invested capital, and if it's greater than MARR, accept the project, less than MARR, reject the project. In today's example, we will see how to calculate the internal rate of return or the true rate of return for a mixed investment using the presented three steps. Example 7.8. A defense contractor has received a government contract from the US Department of Defense worth for 60 million. متعاقد عسكري, شركة تصنيع عسكرية فازت بعقد مع وزارة الدفاع الأمريكية, قيمة العقد for $60 million to build an advanced vehicle for future ground operations. The cash inflow and outflow as shown in the table below. The MARR of the company is 25%. We need to calculate first the net present worth, calculate I star for this project, the internal rate of return for this project, and finally make accept or reject decision based on the internal rate of return. And we have cash outflow 150 million at n equals 0, 100 million at the first year, at the end of the first year, 218 million at the second year, and the cash inflow 50 million at n equals 0, 360 million in the first year and 50 million at the final year. And this is the net cash flow, which is cash inflow minus cash outflow. 50 minus 150 at n equals 0, 360 minus 100 at n equal 1, 50 minus 218 at the end of the second year. Calculating net present worth, minus 100 plus 260 BF 25% and 1 year, minus 168 BF 25% and 2 years, the present worth is $0.48 million. And if we just look at the present worth, which is greater than 0, then based on the net present worth, the project is accepted. Now we need to calculate the internal rate of return for the project. Internal rate of return of the project, this means that the present worth is equal to 0 minus 100 plus 260 divided by 1 plus I minus 168 divided by 1 plus I squared equals 0. Solving the quadratic equation, first we assume we let x equals 1 over 1 plus I. You will get this quadratic equation. Solving the quadratic equation, we will get x equals to 0.833 or 0.714. And solving for I star, we will get two rate of returns, 20% and 40%. And if we go back, this project is non-simple projects. non-simple project because it changes its sign 2 times. Since the sign changes 2 times, we expect 2 rate of returns, and this is what we have got. على non-simple project والإشارة بتتغير مرتين نتوقع يكون في عندي 2 rate of returns، وهذا اللي حصلنا عليه ال 20% and وال 40%. Now since we have multiple rate of returns, then this project is a mixed project. Or if we go to apply the project balance criteria, okay, you will get a mixed project. Okay, and since we have a mixed project, we need to calculate the true rate of return or return on invested capital. Okay, the project balance at the first or at n equals 0 equals minus 100. Now, since the project balance at n equals 0 is negative, then we will use I to calculate the project balance at the first year. So at the first year, project balance is minus 100, the project balance of the previous year. This is project balance at n equals 0 multiplied by 1 plus I, okay, plus 260. We will get this equation, 160 minus 100i. Now, to move and calculate the project balance for n equal to, we have to decide whether to use I, the internal rate of return, or to use the minimum attractive rate of return. For that, we need to know the sign of the project balance in the first year. And the project balance on the first year is an equation. This equation can be positive at certain values of I and can be negative at certain values of I. Therefore, we need to calculate the root of this equation and see which values makes the project balance on the first year positive and which values of I makes the project balance negative. And for that, we need to solve this equation. By solving this equation, we will get I equals 1.6. This means that at I equals 1.6, the project balance is 0. And for any value greater than 1.6, take for example 2, 160 minus 100 multiplied by 2, the project balance is negative. So for any, if I is greater than 1.6, the project balance on the first year is less than 0 or negative. And for any value of I less than 1.6, the project balance in the first year is positive. Take for example 160 minus 100 multiplied by 1 is positive 60. So any value less than 1.6 will make the project balance at the first year positive. Therefore, we should examine both cases because we are still don't know what's the value of I. It can be greater than 1.6 or it can be less than 1.6. So we have to examine both situations that I is greater than 1.6. This means the project balance is negative, and therefore we will use I in calculating the project balance of the next year. And the possibility that I is less than 1.6, this means that the project balance of the first year is less than 0, and in this case we will use MARR in calculating the project balance of the second year. يعني لازم احنا نشوف الاحتمالين انه ممكن اي تكون اكبر من 1/6، هاي راح تخلي البروجكت بالانس عند السنه الاولى نيجاتيف، فمعناته لما بدنا نيجي نحسب البروجكت بالانس للسنه الثانيه راح نستخدم اي، او في احتماليه الاخرى انه اي از ليس ذان 1.6، هذا معناته انه البروجكت بالانس عند السنه الاولى راح يكون بوزيتيف، وبالتالي لما بدنا نيجي نحسب البروجكت بالانس للسنه الثانيه لازم نستخدم MARR. We'll examine the first case, which is I is greater than 1.6. This means the project balance at the first year is negative, less than 0, and we will use I in calculating project balance at n equal 2. Then, this is the project balance of the first year multiplied by 1 plus I minus 168. We will get a quadratic equation. And since we are calculating the project balance at the terminal year في السنة الأخيرة, this means that this project balance is equal to 0. زي ما انتم متذكرين ان البروجكت بالانس at the terminal year should equal 0 at the internal rate of return. Therefore, the project balance, this equation, quadratic equation, is equal 0. Solving this equation, we will get two roots, 0.2 or 0.4, which is 20% and 40%. And you remember that the internal rate of return for this project is 20 and 40%. And also, there is another thing, that I, this is the value of I, is less than 1.6. And if you remember at the beginning, we assumed that I is greater than 1.6. Since the solution violates the assumption that I is greater than 1.6, this solution is rejected. ايش معناته هذا الكلام؟ معناته there's no way that the internal rate of return is greater than 1.6 or 160%. So the rate of return should be less than 1.6, or I is less than 1.6 or 160%. So this solution is rejected. We go to the second case, in which I is less than 1.6. I أقل من 1.6. This means that the project balance in the first year is positive. Therefore, we will use MARR in calculating the project balance at the second year. This is the project balance of the first year multiplied by 1 plus MARR minus 168 equals this equation. And again, since this is the project balance at the terminal year, it should equal to 0. Solving the equation for I, we will get the true rate of return, which is 25.6%. This is the true rate of return for the project, 25.6%. Now we compare it with the minimum attractive rate of return, and if you remember that the minimum attractive rate of return is 25%, then this project is accepted, and it should be accepted. لازم يكون مقبول. ليش؟ If you remember that when we calculated the present worth was greater than 0. Since the present worth is greater than 0, then this project إيش ماله should be accepted, even at the internal rate of return criteria. Now we go to mutually exclusive alternatives. In mutually exclusive alternatives, when we decide between two different options, it's not correct to choose the project with the highest rate of return. If you remember that in the present worth criteria or the annual equivalent or the future worth criteria, we choose the project with the highest present worth or the highest annual equivalent. But this is not always true, or this is not true for the internal rate of return criteria. Let's examine the both situations. Suppose that you have invested $1,000 and at the first year your investment has doubled, then you will get an internal rate of return 100%. You invested 1,000, you got $2,000, استثمرنا $1,000، حصل مقابلهم 2,000 بعد السنة الأولى، في نهاية السنة الأولى، then the internal rate of return is 100%, 100%. On the other situation that you have invested $5,000 and after 1 year you got $7,000. حصلت على 7,000. In this case, the internal rate of return for this project is 40%. So the question is, should I use project A1 or A2 based on the internal rate of return? If your answer was to choose A1, because A1 generates or gives higher internal rate of return. إذا اخترت أنا A1 لأنه A1 مشروع A1 أعطاني أعلى rate of return 100%، يعني أنا ضاعفت المبلغ تبعي. Then this choice is not correct. Let's look at this investment from present worth point of view. If you calculate the present worth for the first project, it's going to be $818. And if you calculate the present worth for the other project, it's 1,364. So based on the present worth criteria, you will choose A2 because it has a higher present worth. انا لو بدي اعتمد على البريزنت وورث كرايتيريا راح اختار المشروع الثاني. ليش؟ لانه اعطاني اعلى present worth. If you remember that we choose the project with the highest present worth. So how this happens that a project with the highest internal rate of return, المشروع اللي له أعلى rate of return ليس بالضرورة not necessarily would be the most profitable project. يعني المشروع اللي له أعلى rate of return مش بالضرورة يكون المشروع الأكثر ربحية أو المربح الأكثر ربحية من ناحية اقتصادية. In this case, in comparing mutually exclusive alternatives, we do not look at the magnitude of the internal rate of return for the individual projects للمشاريع المنفردة. We look at the internal rate of return for the incremental cash flow. إيش المقصود في incremental cash flow? What we mean by the incremental cash flow? We need to calculate the difference between the different alternatives. الفرق ما بين الخيارات المختلفة. Okay? Therefore, we need to calculate what we call it the incremental cash flow, which is B minus A. Okay? This is the incremental cash flow. And we choose B minus A if the first transaction of B minus A at N, or the first transaction, is less than 0, means negative. Okay, we subtract the lowest investment from the highest investment. We subtract the highest investment from the lowest investment. Then we calculate the internal rate of return for the incremental cash flow. Then we use this to make a decision. If the internal rate of return of the incremental cash flow B minus A is greater than MARR, then B is more profitable. If the internal rate of return of B minus A is less than MARR, then we choose A. If the internal rate of return of the incremental cash flow equals MARR, there is no difference between A and B. ما في عندي فرق بين A و B. Okay? But before we proceed to the incremental cash flow, we must make sure that internal rate of return of A and the internal rate of return of B is greater than MARR. يعني في البداية لازم أشوف الانترنال rate of return ل A ولا B وأتأكد إنه الاثنين إيش مالهم أكبر من ال MARR. If one of them is less than MARR, then it is rejected. No need to do incremental analysis. إذا كان عندي الانترنال rate of return ل A أو B أقل من المينيمم attractive rate of return، معناته إيش؟ برفضه وما في داعي إني أعمل إيش؟ incremental analysis. Okay? This is very important to make sure that the internal rate of return of A and the internal rate of return of B is greater than the minimum attractive rate of return before proceeding to the incremental analysis. Now we will see some examples for this. Now, John Covington, a college student, wants to start a small-scale painting business during his off-school hours. هذا شخص بده إيش؟ يشتغل في مجال الدهان أثناء أجازته من الجامعة. He has two mutually exclusive options. He has two options for his investment. The first option, do most of the painting by himself, إنه يعمل كل الشغل بنفسه, okay, by limiting his business to residential painting jobs. Okay, this is B1. The other option is to purchase more painting equipment and hire some helpers to do both residential and commercial painting jobs, B2. The cash flow for the two mutually exclusive alternatives are as shown below. Which project would John select at MARR of 10%? And this is the cash flow for B1, which is doing the painting by himself, and B2 buying more equipment and using helpers. And the internal rate of return for B1 is 25%, and the internal rate of return for the B2 is 17%. Now, since we have mutually exclusive alternatives, we need to calculate the incremental cash flow. But before calculating the incremental cash flow, we must make sure that the internal rate of return of B1 and B2 is greater than MARR. For B1, 25% greater than 10%, then B1 is acceptable. B2, 17.43% greater than 10%, then B2 is acceptable. Now we move to the incremental cash flow. In the incremental cash flow, remember that we subtract the highest investment from the smallest investment, so that we will have the first cash flow is negative. Minus 3,000 minus 12,000. If I took B1 minus B2 minus 3,000 minus 12,000, which is going to be positive 9,000. So this is rejected because it will generate a positive investment. So we reverse it. B2 minus B1, which is minus 12,000 minus 3,000. The answer is minus 9,000. So the incremental analysis should be B2 minus B1 because it will have the first transaction is negative. مهم جدا جدا ان يكون عندي الترانزاكشن اول ترانزاكشن نيجاتيف. تمام. And we proceed 4,200 minus 1,350 to 850. 225 minus 1,800 for 425. And the last year 633 minus 1,500 for 830. Okay, now we calculate the internal rate of return for the incremental cash flow. It's going to be 15%. This is the internal rate of return for the incremental cash flow, 15%. Now 15%, which is greater than the MARR. Remember that MAR is 10%. Since IRR is greater for the incremental cash flow is greater than MARR, we choose B2. So B2 is the most profitable choice. And this is the graphical representation for both for the example. This is the internal rate of return for the incremental cash flow, 15%, and this is for B1 and this is for B2. So you will see that the present worth for the second project is higher than the present worth of the first project at 10%. This is the present worth, which is higher. Okay. Now another example, when we have that the initial investment is the same, how to deal with this situation. We have two mutually exclusive alternatives, and the initial investment for both options is the same. So if we are going to calculate the incremental cash flow, the first year is going to be 0, whether it is C1 minus C2 or C2 minus C1 is going to be 0. In this case, we move to the second year. If I choose C2 minus C1, it's going to be 5,800 minus 480, which is going to be positive. Then this one is rejected. Then it is going to be C1 minus C2. C1 minus C2, 480 minus 5,800. We will get this incremental cash flow. Minus 520, C1 minus C2. In the second year, 3,700 minus 325, 450. The third year, 550 minus 2,000, 4,550. And the fourth year, 3,780 minus 1,561, 2,219. This is our incremental cash flow. Now we calculate the internal rate of return for the incremental cash flow. It's going to be 14.71%. And this is C1 minus C2. Okay? And since the internal rate of return of C1 minus C2 is greater than the MARR, in our example, the minimum attractive rate of return is 12%. So we choose C1. Okay? And one last thing before moving on, we have to make sure that the internal rate of return for each project is greater than the minimum attractive rate of return. The internal rate of return for C1 is 18%, greater than 12%. For C2, 20%, which is greater than MARR. Then both of projects are accepted. We can move to the incremental cash flow analysis. Now, we have now multiple alternatives. I have three alternatives. How to compare between more than two alternatives? When we have more than two alternatives, we compare them pairwise. First of all, I choose, for example, D1 and D2 and see which one is more profitable. And the more profitable one, I compare it with D3. For example, if I compare D1 with D2, I found that D2 is more profitable, then D1 is rejected. Then now I calculate D2 with D3 and decide which one is more profitable. And in our example, we have three mutually exclusive alternatives. As you remember that the first step is to make sure that the internal rate of return for each project is greater than MARR. MARR is 15%, all of them are greater than 15%, then all of them are accepted, then I can move to the incremental analysis. At the beginning we are going to compare D1 and D2. And now we want to find the incremental cash flow. The incremental cash flow is D1 minus D2. If I choose D2 minus D1, it's going to give me positive 1,000. So the first cash flow must be negative. So it's going to be D1 minus D2. Minus 2,000 minus 1,000, which is going to be minus 1,000. And this is the remaining of the incremental cash flow. We calculate the present worth, calculate the internal rate of return, present worth equals 0. We will find that the internal rate of return of the incremental cash flow is 27.76. Since the internal rate of return is greater than MARR, we choose D1. Then the project D2 is rejected. Now we compare D1 with D3 and we need to find the incremental cash flow, which is going to be D3 minus D1. Minus 3,000 minus 2,000, which is minus 1,000. 0, 1,200. Calculate the internal rate of return for the incremental cash flow. It's going to be, this is D3 minus D1, 8.8%. 8.8% is less than the minimum attractive rate of return. The minimum attractive rate of return is 15%. So in this case, we choose D1. D1 is the most profitable project in this case. Last example. Ford Corporation is considering two types of manufacturing systems to produce its shaft coupling over 6 years. The first option, a cellular manufacturing system, It's called CMS. The other option is a flexible manufacturing system, FMS. The average number of pieces to be produced with either systems is 5,400, uh, 5,000, uh, $544,000 per year. Operating costs, initial investment, and sale values for each alternative are estimated as given in the table below. Which project would Falk Corporation select at minimum attractive rate of return of 15%? So we have the summary of the project. This is annual labor cost, annual material cost, annual overhead cost, annual tooling, annual inventory cost, annual income tax. All of them are ايش؟ cash outflow. This is the total annual cost for each project, the cash outflow, and this is ايش؟ the investment, the initial investment. Okay, and this is the salvage value. Now, this example is a little bit different. We have two mutually exclusive alternatives, but both of them are investment projects. We can still compare mutually exclusive in alternatives even though they are investment projects. If you see that there is no revenue in this case, the revenue is the same for both projects. Therefore, they are investment projects because the revenue doesn't change whether I choose CMS option or choose FMS option. The revenue is the same. Okay, now how to compare between investment projects? In comparing between investment projects or service projects, we do the same thing. I need to calculate the incremental cash flow, and for the incremental cash flow, the first cash flow should be negative. Whether I'm choosing FM, it should be negative. So it's going to be FMS option minus CMS option, which is going to be 12,500,000 minus 4,500,000. 12 مليون ونص ناقص ايش؟ 4 ملايين ونص. ناقص 4 ملايين ونص, which is going to be minus $8 million. And the same for the remaining projects. 5,504,100 minus, by the way, this is minus and this is minus, so it's going to be minus 5,504,100 minus 7,412,920. So the cash flow is going to be positive 1,908,820 dollars, and the last year is going to be 1 million minus 5 million, the salvage value. Now this is the incremental cash flow of the FMS minus CMS options. Okay, now we need to calculate the internal rate of return, solving the present worth equals 0. We will get internal rate of return of 12.43%. Since it is less than MARR for this company is 15%. Since it is less than 15%, we will choose CMS option. Okay, and this is just summary for the internal rate of return chapter. Rate of return, different definitions of the rate of return is the interest rate earned on uncovered project balance, or that it makes the project balance at the terminal year equal to 0. Managers or companies prefer to use the internal rate of return over the net present worth method. Internal rate of return is another term for ROR. It is concerned with the portion of the project that it is internally invested, not with the portion that is released by borrowed from the project or released by the project. Mathematically, we calculate the internal rate of return by making the solving the equation net present worth equal to 0, and we call it the break-even interest rate, I star. We apply rate of return analysis. We need to classify the projects to simple and non-simple investments. Simple investment is defined as one in which the initial cash flow is negative and changes the sign only one time. Non-simple investments, it changes the sign, the cash flow changes its sign more than one time. And for multiple I stars occurs in non-simple investment. And not all non-simple investments will have multiple I stars. Therefore, a unique positive I star for project doesn't imply a simple investment. Okay? And we classified the investments to pure and mixed investments. Pure investment, we just simply compare internal rate of return versus MARR. If it's greater than MARR, accept. Less than MARR, reject the project. For mixed investments, we need to calculate the true rate of return or the return on invested capital and apply the same rule as pure investments, but in this time we compare RIC with MARR. And for mutually exclusive alternatives, we do incremental analysis and calculate the internal rate of return of the incremental cash flow and compare it with the minimum attractive rate of return. And by this we come to the end of this chapter. Assalamu alaikum.